Welcome to INF154 Introduction to Programming Part 3. So this session is going to be separated into two parts. So in the first part, we are going to finish the theory. So this is going to be a very short video. Then in the last part, we are going to apply everything and code. So we are going to study local variables versus global variables. So a local variable is declared inside a specific event handler method, can only be accessed by the function or the method that declared it. And a global variable is one that is declared outside the function or event handler method and can be accessed by any functions or any event handler method. So for the global variable, the global variables hold their value throughout the lifetime of your program. So if we consider this diagram, we have this int which is defined outside these two methods. So these two methods can access this variable because it's global. It doesn't belong to any function. Then we have this local variable int sum equals to 0. This sum can only be accessed inside method 1 because it's declared inside method 1. In method 2 cannot access that specific sum. Then let's see an example of how this works. So let me create a basic form. So I'm going to say maybe button. Then I will put a button here. Then I'm just going to name it anything, maybe btn click or btn submit, something like that. Then the text is going to be submit. So for the text, I'm going to put submit. Then I double click on this button to get the event handler method. So I'm going to get this function. Then I can put another button. So I can go to the form design. Then I can copy this button, copy and paste. This one I'm going to call it something different. Maybe show. And I'm going to change the text to show. So I was supposed to say btn show for the name, btn show. Then when I double click on this button, I have these two different methods. So we have private void btn submit for the submit button and private void btn show. These ones are called methods. In this case, they are event handler methods because they they respond to a certain event. In this case, it's the click event. So I'm going to define a variable inside this submit, maybe int sum equals to 0. Then I'm going to say message box dot show. Then I'm going to say sum. Then I'm going to convert this to string. Then let's execute this and see how it works. So it's building. Okay, it's still building. And it's still building. Then now it must be done. So when I click submit, I'm going to get this 0 because I displayed the result on a message box. Every time I click this submit, it's going to initialize the sum to 0, then display that sum to 0. Then let's say I have some outside, before that one, let me try to access some. Let me say message box dot show. Then I'm going to say sum. say sum, then like this, and see what's going to happen if I try. So automatically I'm going to get an error. So it says the name sum does not exist in the current context because this sum was declared inside this specific method. It's global. It cannot be accessed outside this method. How can we fix this? We want both methods to access this specific sum. So I'm going to declare it outside of these methods. I'm going to say int sum. Then I'm going to remove this line. Then here I can say, okay, my sum equals to 0. Then I can say, let me initialize it first. Let me say sum equals to 0. Then let me say sum equals to 10 for this one, and here I can say sum equals to 20, something like this. So we declared the sum as a global variable because it's outside this specific, it's outside the event handler methods. So now I can, here I need to convert to string. So now I can access this sum on both event handler methods. So that's, it's global. It can be accessed outside, or it can be accessed by any method or event handlers. So when I execute this now, I'm going to get something like this. So initially my sum is 0. If I click submit, submit is going to set my sum to 10. So I'm going to get 10. Then when I click show, because we click the submit, sum is equals to 10, so it's going to remain as 10 since it's a global variable. Then when I click show, it must change to 20, so which is 20, and it will remain at 20 until I do something. So that's the difference between local and global variables. We will see an application of this in the second part. So before we go into the other part, let's consider mathematical operations. So for mathematical operations, we have the addition operator, the subtraction, the division, multiplication, and the remainder. These are the corresponding symbols. So for addition, we have a plus. For subtraction, we have a minus. For division, we have this. Multiplication, this. And remainder, we have this. So addition. So for addition, we add two operands. So whatever is on the left of the plus is called an operand. Whatever is on the right of plus is called an operand. So it adds two operands. For example, if I have a variable int a equals to 10, b equals to 20. So in memory, it's represented like a, which stores 10, b, which stores 20. Then I say int sum equals to a plus b. So with the addition, we are going to add 10 plus 20. The result is going to be stored in the sum variable. So sum at the end will be 30. Then for subtraction, it subtracts the second operand from the first operand. So also you should just say double. Let's say you have double a equals to 10.5, b equals to 20.5. Then I declare an integer d equals to b minus a. So here I made a mistake. It was supposed to be convert to int32 if I want to store this in an integer, or I was supposed to declare this as a double. So I'm going to have this 10.5 and 20.5, so it's going to be 20.5. The second b minus a minus 10.5, which is 10. So this is going to store 10. Then we have the multiplication. So for the multiplication, it multiplies both operands. So if we have int a equals to 30, b equals to 2, then I say m equals to a multiplied by b. So I'm going to have a, which is 30 in memory, b, which is 2, then 30 times 2, which is a times b, it's 60. So it's straightforward. The way you did in school is the same thing. So division divides numerator by denominator. So for division, we have two types of division. So we have the integer division and the normal division. So this integer division applies to integers. This normal division applies to doubles or decimal numbers. So for integer division, divides two numbers and returns an integer. For example, let's say we have int a, which is 5, then we have your b, which is 2. Then I say int q equals to a divided by b. So in memory, my a is going to be represented. It's going to store 5 and my b is going to store 2. Then a over 2, you can rewrite this mathematically using a over b, which is 5 over 2. We know that 5 over 2 is 2.5. Because these are integers, we are going to ignore everything after the decimal. So it's going to store 2. So you have to be careful when you are doing division. Then another example, we have int a equals to 3, b equals to 4. Then I say int q equals to b over a. Then my a is 3 in memory, b is 4. b over a is 4 over 3. Then which is 1.333 mathematically, but we are going to ignore the decimal part since this is an integer. We are not rounding up or we are not rounding off because it's an integer. We ignore everything, so the result will be 1. Then another example, int a equals to 40, b equals to 20, then int c equals to b over a. That a is 40, b is 20, b over a is 20 over 40, which is 0.5. Because this is integers, we are going to ignore the decimal part, so the result will be 0. We are only interested in the whole number part. Then the normal division gives you the decimal points part. Then now we can move to the next operator, which is your remainder or your modulus operator, which is represented by a percentage. So this operator returns the remainder of an expression when the first operand is divided by the second operand. So it returns the remainder or the leftover when you divide two numbers. So this applies to integers only. For example, let's say you have a percentage b. This means that what is the remainder or the leftover of a percentage b when a is divided by b. So let's see an example. For example, find the remainder of, for a we want 5 percentage 2. So what's the result? We know that 2 can go into 5 2 times and the leftover will be 1. So the remainder will be 1. The way it is in maths, the remainder is 1. Then 6 modulus 3 or 6 remainder 3, it's going to return 0 because 6 is divisible by 3. It's fully divisible by 3 without leaving anything. So let's say we have int a equals to 10, b equals to 7, then we say int c equals to a percentage b. Then in memory we have this a which is 10, then we have this b which is 7. Then 10 modulus 7 is 3 because 7 can go once into 10 leaving 3. So the remainder is 3, the leftover is 3. So now let's consider an interesting case. What is the result of 5 modulus 10? So is 5 divisible by 10? No. So if that's the case, the general approach is if a is less, let's say you have a modulus b, if a is less than b, the remainder is a. So in this case, 5 modulus 10, 5 is less than 10, so you cannot divide 5 by 10, so the remainder will just be 5. 5 is going to be left as it is. Then as I explained, 1 modulus 2, it's 2 because 1 cannot be divided by 2. So we leave 1 as it is. Then 6 modulus 20. 6 cannot be divided by 20, so we leave this as it is. Then we have this shorthand, then we have operator equals to operations. So how do we handle this? Let's say a plus equals to value. This is the same as saying a is equals to a plus value. A multiply equals to value. This is the same as a is equals to a multiplied by value. A divide equals to value is the same as a equals to a divided by value, and so on. So a simple example will be sum equals to 0. You have sum equals to 0, then you say a equals to 10, b equals to 20, c equals to 30. Then I say my sum plus equals to a. So this is the same as saying sum is equals to sum plus a. What's the current value of sum? The current value of sum is 0 plus a, which is 10. So we are adding a to our existing sum. That's what it means. Then sum plus equals to b plus c. It's the same as sum is equals to sum. So when you see plus equals to, you are just repeating this. So it's the same as sum plus b plus c. So in this case, we have our current sum. The one we updated was 10. Then plus b, which is 20, plus c, which is 30. So the result will be 60. Then you can do the same with other operations. Then now we have the order of operations, or in maths we know it as BODMAS or PETMAS. So in case of programming, brackets have they have the highest precedence, then followed by multiplication, division, and modular. So these three have the same precedence. Immediately after brackets they follow, but they have the same precedence. Then after them, plus and minus follow. These ones have the lowest precedence. So the order is parentheses, which are your brackets. Then you can either have multiplication, division, modulus. They have the same precedence. Then plus, minus, they also have the same precedence. In terms of evaluating expressions, we are going to evaluate expressions from left to right. Then simple examples, we have evaluate the following. So we check, okay, we are going to move from left to right, but first we have to consider which operations have the highest precedence. So in this case, these 1, 2, 3, they are equal, and 4, they are equal. So it's like I'm putting brackets here because they have the same precedence, then brackets here. Then I'm going to evaluate from left to right. So from my left, I have 4 divided by 3. These are integers. So 4 divided by 3 is going to be 1. Even though it's 1.3333, because it's integer division, it's going to be 1. Then at the end I have this 1 times 6 divided by 2 plus 8, then modulus 3. Then I'm going to evaluate this. What is 1 from left to right? 1 times 6 is 6. Then I'm rewriting divide by 2 plus 8 modulus 3. Left to right again, but here I have these brackets. 6, I evaluate 6 divide by 2 first, which is 3. Then I can't evaluate plus yet because plus has a low precedence than modulus. So I'm going to evaluate this again. What is 8 modulus 3? 8 modulus 3 is 2, because 3 can go into 8 2 times, leaving 2. So I'm going to have this 2, then I add 3 plus 2 and I get 5. Then another example, so we have this: assume x equals to 3, y equals to 5, z equals to 6. Normally we get these kind of questions on your multiple choice. So we want to evaluate x minus 3 plus y multiplied by 2 minus z over 2. So I'm going to move from left to right, but first I'm going to identify things that, or operations that have the highest precedence. In this case, I have this multiplication. I'm going to put brackets. Z divided by 2, they have the highest precedence. So I'm going to leave x minus 3, evaluate this, which is 10, because y was 5. 5 times 2 is 10. Then z divided by 2, z was 6. 6 divided by 2 is 3. So at the end I have this. So if I have this, all of them, they have the same precedence. I can move left to right or from right to left. It doesn't matter. At the end I'm going to say, if I start here, x minus 3, x is 3, 3 minus 3 is 0, plus 10 minus 3, I'm going to get 7. Then another example is assume x equals to 3, y equals to 5, z equals to 6. Then evaluate x divided by 3, y divided by 3 plus x, then multiplied by z modulus x. So I'm going to start from left to right. First, I have brackets, so this is my priority because it has the highest precedence. Then inside the brackets, this takes over divide. I'm going to start with the divide. So y divided by 3, so y is 5, divide by 3, it's 2 comma, it's let me see, y divided by 3, 5 divided by 3. I think I made a mistake here. The answer was supposed to be 1 in this case, because 5 divided by 3, I think it must be 5 over 3, 5 over 3, let me see, 5 over 3, it can't be 2, it must be 1.6 something, or yeah, 1.6 something. So this was a mistake. Or 1.33, must it be 1.33? 3 times 3 is 3, somewhere there, but it's not supposed to be 2, it must be 1 here. I made a mistake. So I'm going to have 1 plus x, then I rewrite the whole expression. Then I'm going to evaluate this. It's going to be 1 plus x. Our x it's 3 in this case. So 1 plus 3 is 4. This was supposed to be 4 also, multiplied by, now I rewrite the whole thing. They have the same precedence. I'm going to move from left to right. So it's going to be 4 times z, which is 4 times 6. 4 times 4 times 6. 4 times 6 is what? 4 times 6 is 24. So 24 remainder x, which is 3, it's 0. So the answer must be 0. So the answer must be 0. So you guys have to figure out, why is this wrong? So that was a mistake that I made. Then I think for this part we are done. Next part is where we are going to start coding.